So carrying on with our tangent theorems, probably the most famous of all the circle geometry theorems, the alternate segment theorem. So there it is in words: the angle formed by a tangent to a circle with a chord drawn to the point of contact is equal to any angle in the alternate segment. Bit of a mouthful. Let's look at the picture and see what it's talking about. But basically, here it is, BPX. It's called the alternate segment theorem because that chord BP is breaking up the circle into two segments. So one is an angle in the minor segment, BPX. It's equal to the angle in the other, or the alternate segment, BAP. So you look at the chord and you say, well, okay, it's got to be subtending an angle in the other segment. That's the one that's going to be equal. Alternate segment theorem is fine for a reason. Because there is only one alternate segment theorem. So if you write alternate segment theorem, we know what you're talking about. Okay? Let's prove it anyway. So I want to prove APY is the same as ABP. So I'm going to again draw in some lines here. In fact, I'm just going to draw a diameter. Why didn't I say draw a diameter? Join PO and produce to meet the circumference at Z. I suppose it's a fancy way of saying draw the diameter anyway. Okay. And I'm also going to join up AZ as well. All right. We know ZPY, because now I've made that a diameter. We've got radius perpendicular to tangent. So APZ will be 90 minus APY. PAZ becomes the angle in a semicircle. So PAZ is 90. But I also have a triangle APZ. Those three angles must add to give 180. So let's substitute in. We said PAZ was 90. AZP is AZP. APZ we said was 90 minus APY. So we end up with that AZP is equal to APY. Well, that's not what we were trying to prove. But I can also say AZP is the same as ABP, angles in the same segment. Well, now I can conclude that APY is the same as ABP. And that's what we were trying to prove. So there's our alternate segment theorem proven. And that's all for today. So at 9F, playing with our alternate segment theorem.